Bismillahirrahmanirrahim. We are still in this topic, which is the derivatives of the logarithmic functions. In the last part, we said that the derivative of the logarithmic function d by dx of then f of x is equal to f of x down and the derivative up is f prime divided by f of x, and if the base is not equal to e, then we will add ln b in the denominator. That's what we have discussed last time, and we gave different type of examples. For this part now, we are going to give more examples about derivatives of logarithmic functions. But before that, let's just state the properties of the logarithm. Number one, v1 log base b of x multiplied by y is equal to log x plus log of y. The logarithm of product of two quantities will be the logarithm of the first one plus the logarithm of the second one. Second property, P2, log of x divided by y is equal to log of x minus log of y. For the division, it is difference between the two logarithms. Third one, logarithm of x to power n. The power will be product is n multiplied by x. And number 4, log p to power x. If we have the same basis for the logarithm and the exponential function, then we'll have only x. Same thing for the reverse if it is b to power log of b of x. These are the basic properties for the logarithm. In this part, we are going to use these properties to find the derivative for some functions. Find y prime. Number 1, y equal to ln of cosine to power 2x multiplied by square root of 1 plus x squared. I have ln of x to power 2x multiplied by square root of 1 plus x squared, and we need to find the derivative y prime. Either we can do it by the previous one, with technique that we found that the derivative is f prime divided by f of x, but in our case, in this example now, it is a little bit hard because I have cosine to power 2 multiplied by square root of 1 plus x squared, and by the chain rule, so I have 4 functions, plus I have to apply the product rule because it's the product of 2 functions. Cosine square multiplied by 1 plus cosine square. And inside each one of these, I have 2 functions, the power and the cosine for the first one, and also the power and 1 plus x squared in the second function. So it is a little bit hard. So we need to simplify it first, then we differentiate. And to simplify, we are going to use the properties of the logarithm. From the properties, I have this product will be plus of two logarithms. So it will be ln of cosine x plus ln of 1 plus x squared to power 1 half. Can you simplify it more? Yes, because we have the power. So the power will be coming out as 2 multiplied by ln of sine x plus 1 half ln 1 plus x squared. Now we can differentiate. After we simplified, now we can differentiate. So y prime is equal to 2 multiplied by derivative of ln, the function down, and the derivative of the function which is minus sine will be up. So it is minus sine x divided by cosine x plus 1 half. The function of the logarithm is 1 plus x squared down, and the derivative of this one is 2x will be up. So it is 1 half multiplied by 2x divided by 1 plus x squared. We can simplify it more to write it as y prime equal to minus 2 sine over cosine is tangent. This 2 will cancel with this one plus x divided by 1 plus x squared. So this is the derivative. So if we simplify, it will be easier than direct differentiation. But what we did, just simplify it using the properties of the logarithm. Let's take another one. Suppose that y equal to ln of cosine x, let's take this time tan x divided by square root of 1 plus 3x to power 3. And we need to find the derivative of this function. We can do it directly, but it will be complicated a little bit. So let's simplify it using the logarithm properties. Now this one, it is division. So it is y can be written as ln of tangent minus ln of 1 plus 3 x to power 3 to power 1 over 2. For the division, it is negative. Ln of tangent minus ln of 1 plus 3x to power 3 or to power 1 half because I have square root. So it is to power 1 half, which is equal to ln of tangent minus 1 half ln of 1 plus 3x to power 3. Now we can differentiate this one. Y prime equal to derivative of ln is the function is down and the derivative of the function which is secant square. So it is secant square x divided by tangent of x minus 1 half. The function is 1 plus 3 x to power 3. Derivative of this function will give me 9 x to power 2. So this is the derivative of the given function using logarithmic differentiation. Just simplify it first, then differentiate. That will be easier to find the derivative of the given function. In some cases, the function is more complicated without any logarithm. For example, this is number 4. I have, for example, that y equal to, let me take this function which is x to the power 2 multiplied by x squared plus 1 divided by x to the power 5 minus 3x plus 7. And I need to find the derivative for this one. I have in the numerator this product x squared minus 8 multiplied by square root of x squared plus 1 divided by x to the power 5 minus 3x plus 7. To find the derivative in the classical way, in the old techniques, or by product and quotient rule, this will not be easy. It can be found, but it will not be easy. I have to apply sometimes chain rule, product rule, quotient rule, all of these in this problem. To make it easier, we are going to simplify it first. Step number 1, take len. Take len to the both sides of the function, left and right hand side. So I'll have len of y equal to len of square minus 8 multiplied by x square plus 1 to the power 1 half divided by x to the power 5 minus 3x plus 7. We took len for the both sides of the equation. Now simplify. This is step number 2. Simplify it. Len of y equal to, using the properties of the logarithm. In the numerator I have product, so this will be len of x squared minus 8 plus len of x squared plus 1 to the power 1 half, and then we have division. Division it is should be written as negative minus len of x to the power 5 minus 3x plus 7. Because I have power, this one more. This is equal to len x squared minus 8 plus, the power will be written down, this one, 1 half len of x squared plus 1 minus len of x to the power 5 minus 3x plus 7. Now differentiate. After we simplify it, we differentiate. Step number 3. Differentiate. Now for the derivative, we have to be careful about the left hand side. The left hand side is not y, it is len of y. Again, left hand side is len of y. We have to differentiate the left hand side and the right hand side. The derivative of the left hand side, it is len of y, that will be y prime divided by y. This is derivative of we differentiate len of y, which is y prime divided by y. Now the left hand side, let's take the first one. Derivative of len of x squared minus 8. Again, the function is down. And the derivative up to x divided by x squared minus 8. Plus, second term, this is 1 half multiplied by, again the function is down, x squared plus 1, and the derivative is 2x up, minus, third one, the function which is down, that is x to the power 5 minus 3 x plus 7 down, and the derivative is 5x to the power 4 minus 3 up. So this is the derivative of the left hand side. Now in the right hand side, the left hand side is y prime divided by y, and we need to find y prime only. So y prime is equal to just a cross multiplication. It will be y multiplied by all of these. That is 2x divided by x squared minus 8 plus, I can cancel half with 2. It will be only x divided by x squared plus 1 minus 5x to the power 4 minus 3 divided by x to the power 5 minus 3x plus 7. So this is the derivative of the given function. If you are given a very complicated function, you can simplify it first by taking the length for the both sides, left hand side and right hand side, then simplify it and differentiate it. Let's take one more. Example number, that was number 4. No, it should be 3 and 4. No, this is 3. No, it is 4. Example number 4. Let's have that y equal to sine x multiplied by cosine x multiplied by tangent to power 2 x square root of x multiplied by e to power, let's have x square minus 1. And I need to find the derivative of this function. And you can see this is very complicated. So let's simplify it by taking the length to the both sides of the equation. So step number 1, take length. So I will have length y equal to length of all of these sine x multiplied by cosine x multiplied by tangent square divided by square root of x multiplied by e to power x square minus 1. Now simplify. Step number 2, expand or simplify it. That is length of y equal to, it will be length of sine x, the first one, then plus length of cosine plus length of tangent square. And for the denominator it is minus. Anything down will be negative. It is minus length of x to the power 1/2. Again we have minus length of e to the power x square minus 1. And this is equal to length of y is equal to length of sine x plus length cosine x. I have power, so I will write it outside. It is 2 multiplied by ln of tangent. Minus, I have power, it is minus 1/2 ln x minus the last one. I have ln and the base e. This is ln means, this is means log with base e. And if we have log and exponential function, these will cancel each other. I will have only the power, because the exponential function and logarithmic function are inverses of each other. So they are removing these bases. So ln and e will cancel each other. I will have only the power. So the last one is equal to minus x squared minus 1. This is one of the properties of the logarithm. Now we can differentiate. Step number 3. Differentiate. Now the left hand side, don't forget that is ln y. So it is y prime divided by y, which is equal to now derivative of ln of sine down, and derivative is cosine, which is up. Second one, ln of cosine, the derivative will be cosine is down, and the derivative is minus sine x divided by cosine x. Third one, 2 multiplied by tangent is down in the denominator, and the derivative is secant squared minus 1/2 ln of x will be 1 over x, and last one minus derivative of x squared, it is 2x minus 1 will give me 0. The derivative of minus 1 is equal to 0. So this is the derivative of the right hand side, and we have just one more step, that is I have to multiply by this one. So I have y prime equal to y multiplied by cosine over sine is cotangent minus tangent plus 2 multiplied by secant square divided by tangent minus 1/2 x, I'm sorry, 1 over x, not x. This should be 1 over x minus 2x, and that's it. So this is the derivative of the given function. As you can see, what we did, we took ln to the both sides, left hand side and the right hand side, then we simplify it, and in the last step we differentiate the simplified form to find the derivative. In this way it is easier than differentiate the equation directly, because it will be complicated. I have more than 5 functions there. I have to apply the product rule 2 times and quotient rule plus other things. So to make it easier, take ln. If you have very complicated function with product and division, take ln, then simplify it, then differentiate to find the derivative.